In this video, we're going to be taking a look at the concept known as polymorphism. And although you can get by in your Python programming without knowing this concept, as you just use it naturally, it's worth touching upon this concept to get to grips with how it can be useful in Python programming. Now, there are different types of polymorphism, and we'll run through some examples now to showcase what it is. So what is polymorphism? Well, the literal meaning of polymorphism is the condition of occurrence in different forms. So for example, we could use a single type, so a method or an operator of some kind, and use it on different types or in different scenarios. So let's take a simple example of the plus operator. If I create a variable called num1 and set this equal to 5, and then create a variable called num2 and set this equal to 10, when we perform the operation num1 plus num2 utilizing the plus operator, you can see that we return 15. So the plus in this instance is used to plus two numbers together. Now we can also use the plus operator in a different scenario. So for example, if I put string 1 and set this equal to hello, and then I create a variable called string2 and set this equal to world, you can see that if I then put string1 plus an empty space plus string2, we return hello world to the screen. So in this example, the plus operator is used to concatenate strings together. In the first example, we added numbers. In the second example, we've concatenated strings by utilizing the same plus operator. Now, this is one of the most simple occurrences of polymorphism in Python. So let's move on to a slightly different example where we use a built-in function. There are some functions in Python which are compatible to run with different data types. So you can use it with strings, you can use it with dictionaries, but the function itself will operate irrespective of the type you use. One example of this is the built-in len function. So for example, if I print the len of the string Dean, and secondly print out the len of a list which contains the strings golf, badminton, and football, and finally print out the len of a dictionary where the first key is name with an associated value Sally, and the second key is age with an associated value of 45, you can see that when I run this code cell, we print to the screen 4, 3, and 2. So we can see that the different types here that are being passed into the len function. In the first row, we have a string. In the second row, we have a list. In the third row, we have a dictionary. The built-in len function works irrespective of the type that's passed in. So the length of string is bringing back the number of characters in that string. Passing in a list will bring back the number of items, and passing in a dictionary into the len function will bring back the number of keys. Once again, another example of polymorphism. Now, polymorphism is a very important concept when it comes to object-oriented programming. And we can use the concept of polymorphism while creating class methods, as Python allows different classes to have methods with the same name. We can then later in our program call these methods on different objects by disregarding the object that we're working with. So let me show you an example. If we first of all create a class called dog, and then create an init method, so we can put def dunder init dunder, we can pass in self as the first parameter, name as the second, and age as the third. We can then put a colon. We can then put self.name equals name, and then self.age equals age. We can then define a second method called description, so we can put def description, brackets self, and then we can simply print to the screen, I am a dog, my name is parentheses, full stop, I am parentheses years old. I can then use the format method, and we can pass in self.name as the first argument and self.age as the second. We'll create a third method called speak, so we can put def speak. we'll pass in the keyword self, and then we will simply print bark. I will then copy and paste this dog class, and I'll relabel the class to be cat, and I'll change the description to print I am a cat. In the speak method, we'll simply change bark to be meow. So here we've created two classes, a dog class and a cat class. You can see they share a very similar structure and have the same method names, description and speak. Now you'll also notice that we haven't created a common superclass or linked the classes together in any way. In other words, they don't inherit from the same parent class or don't inherit from each other. But even though they're not linked, what we're able to do is create two instances, so dog1 equals a call on the dog class, we'll pass in the name Dolly with the age 4, we'll then create an instance of the cat class, so we'll put cat1 equals cat, we'll pass in the name Felix, who has the age 2. Now what we're able to do is pack these two different objects into a single tuple and iterate through the objects using a common name. So we could put for animal in and then brackets cat1, dog1, which is our tuple. We can then put a colon. We can then call upon the respective methods. So we could put animal.speak. We could then put animal.description. And then we could put animal.speak. Now before I run this code cell, what do you think will get printed to the screen? Well, firstly, we're iterating through an object that is of the type cat. So we first of all print the speak method to the screen, so we have meow. We then have I am a cat, my name is Felix, I am 2 years old, which is because we've called upon the description method. And finally we print meow as we call the speak method for a second time. Once we've iterated through the cat object, we then move on to the dog object. So we then print bark, we then have I am a dog, my name is Dolly, I am 4 years old, and then we bark again. Now this is made possible due to polymorphism. Class structures that contain the same method names which are not linked in any way, apart from the names of the methods used, and we're able to iterate through them as if they are one. All made possible due to the concept of polymorphism. So certainly a concept to be aware of, and you've been using the concept throughout the course so far without even knowing. If you're interested in understanding polymorphism in more detail, I've attached some material in the resources section for further reading if you so desire. In the next video, we're going to be taking a look at what are known as special methods. Now we've seen some special methods so far in this section, but we're just going to take it one step further to really ensure you understand how special methods can benefit you when creating class objects. So I'll see you in the next video.